I'm trying to prove this relationship for all n is equal to greater than equals to 1 using mathematical induction. So as the first step, I will try showing them for the first value of n, that is n is equal to 1, trying to show that the left hand side is equal to right hand side. So when n is equal to 1, the left hand side becomes basically 5.5 times 1 plus 4 is equal to 9, and right hand side becomes 5 1 square plus 13 1 over 2, so that's 18, actually 18 by 2 9. So left hand side is equal to right hand side for n is equal to 1. Now we assume that the relationship is true for n is equal to k when k is another integer, any integer basically, and we assume that the relationship is true. So when n is equal to k, 9 plus 14 plus 19 plus 5k plus 4 is equal to the right hand side is 5k square plus 13k over 2. So this is true, we are assuming, and from there we are trying to see what happens. We will try to prove that this for n is equal to k plus 1. If this is true, we will try to show that the relationship is true for n is equal to k plus 1. If we can show that, we will be able to prove that the left hand side is equal to right hand side using mathematical induction. This is the method. So when n is equal to k plus 1, the left hand side becomes 9 plus 14 plus 19 plus 5k plus 4, then plus 5k plus 1 plus 4. Now this one is when n is equal to k, and that is equal to right hand side. We have assumed that. So 5k square, I will write, instead of the series, I will write the right hand side, and the left hand, the remaining part, which is this one, is 5k plus 5 plus 4, that is 9. So if I get rid of the bracket, that becomes 5 here. 5 times 1 plus 4 is equal to 9. So there. So it's 5k square plus 13k plus 10k plus 18 over 2. So 5k square plus 23k plus 18 over 2. So we can try writing it like this way: 5k square plus 10k plus 5. So here I have taken 10k, so I have to make 23k, so 13k there, and then here I have taken 5, so I have to make it 18, so 13 remaining. So it's 2 there. So the reason I have written it like this is I want to take 5 out. It becomes k square plus 2k plus 1, and then here remaining part is 13k plus 13, 13k plus 13, so 13k plus 1, and this is 2. So this one can be written k plus 1 whole square plus 13k plus 1 is equal to 2. Now this one will be the right hand side when n is equal to k. So I will just leave it there and then look what the right hand side becomes when n is equal to k plus 1. So that's actually 5k plus 1 whole square plus 13k plus 1 over 2, because the right hand side was 5n square plus 13n over 2. So when n is equal to k plus 1, it becomes 5 into k plus 1 whole square plus 13k plus 1. So this is the left hand side basically. So we have shown that the relationship is true. The left hand side is equal to right hand side for n is equal to k plus 1 when when the relationship is true for n is equal to k. So substituting k with any integer, we can show it's true for all n is greater than equals to 1, because we started from by showing when n is equal to 1 the relationship is true. So we have proved the relationship using mathematical induction.